So the next set of properties involve inequalities. So the eighth property is that modulus of Z1 plus Z2 is always less than or equal to mod Z1 plus mod Z2. So modulus of Z1 plus Z2 will always be less than or equal to mod of Z1 plus mod of Z2. Similarly, mod of Z1 minus Z2 will always be less than mod Z1 minus mod Z2. So we can see the logic of this clearly when we deal with geometry of complex numbers. And modulus of Z1 plus Z2 will always be greater than or equal to mod Z1 minus mod Z2's magnitude. So if you have mod Z1 and mod Z2, if you subtract one from the other, the magnitude of that will always be less than modulus of Z1 plus Z2. Similarly, mod of Z1 plus Z2 is always, mod of Z1 minus Z2 is always greater than or equal to mod Z1 minus mod Z2 whole mod. So these four properties are called triangular inequalities. So triangular inequalities in complex numbers. So the next property, which also consists of inequalities, is that the real part of Z will always lie between mod Z and minus mod Z. The real part is nothing but x will always lie between square root of x square plus y square and minus square root of x square plus y square. I can also write it as mod of real part of Z. So if I write mod of real part of Z, then I don't need to go for the negative side. Even if I don't have the mod, this real part of Z will always lie between minus of mod Z and plus of mod Z. And similarly, imaginary part of Z will also lie between minus of mod Z and plus of mod Z. So this is also a very straightforward property. So the next property is, so mod Z is equal to 0 implies Z has to be equal to 0. So there is only one complex number whose mod is equal to 0, which is 0. But mod Z is equal to some other number which is not equal to 0 does not imply Z is equal to A. For example, if you have mod Z is equal to 1, mod Z is equal to 1 does not imply that Z is equal to 1. You cannot write this. Because mod Z is equal to 1, the meaning of this is that the distance of Z from origin is equal to 1. The distance of Z from origin is equal to 1. That does not mean Z has to be exactly equal to 1. You can have many different complex numbers whose magnitude is equal to 1. That is, if you draw a unit circle, every complex number on this, every point on this circle will have mod Z is equal to 1. 1 is one of them. So you cannot say that mod Z is equal to 1 implies Z is equal to 1. But this is true for mod Z is equal to 0. So the next property that we are going to discuss is a very easy property. The property says that mod Z will be exactly same as mod of Z bar, will be exactly same as mod of minus Z, will be exactly same as mod of minus Z bar. So mod Z will be equal to mod Z bar, will be exactly equal to minus of mod Z is equal to mod of minus Z bar. So all these complex numbers will be at the same distance from the origin. This can be very easily understood from the geometrical interpretation of complex number. That is, if you have the organ plane, so if Z is a complex number somewhere here, let us take this as x comma y, that is x plus iy. What is the conjugate of this? The conjugate of this is x minus iy. That is the point x comma minus y, the exact mirror image about x-axis. What is a complex number minus Z? Minus Z is nothing but minus x minus y, which is nothing but the image of this about origin. And what is minus Z bar? z bar is x minus iy minus z bar is minus x plus iy, which is this point. So you have all the 4 points forming a rectangle symmetric about origin. Hence, all the 4 distances will be same. So mod z will be same as mod of z bar, will be same as mod of minus z, will be same as mod of minus z bar. So this is one of the very simple properties of modulus. So the next property that we are going to deal is that modulus of some real number times z. Modulus of some real number times z is nothing but modulus of that real number times mod z. If you have modulus of 2z, can be written as 2 times mod z. That is, if you just multiply the complex number with 2, if you have x plus iy, the value of 2z will be 2x plus 2iy, that is 2x comma 2y. This is 2z. So the mod of 2z will be exactly 2 times mod z. So once you remember all these properties, so these properties will be useful in various stages of solving problems based on conjugates and moduluses. So now let us try to look at some problems based on these properties.